Hi guys, this is Vicky. So today we're going to go through the 2014 question number 5 AP Chem FRQ. Alright, so question number 5, it says some binary compounds that form between fluorine and various nonmetals are listed in the table above. A student examines the data in the table and poses the following hypothesis. The number of F atoms that will bond to a nonmetal is always equal to 8 minus the number of valence electrons in the nonmetal atom. Based on the student's hypothesis, what should be the formula of the compound that forms between chlorine and fluorine? So let's look. So if it's the formula of the compound that forms between chlorine and fluorine, if it's 8 minus the number of valence electrons, so 8 minus number of chlorine's valence electrons is what? Chlorine's valence electron is what? 7, right? So that would be just 1. So for question A, it would just be Cl bonded to F, right? Cool. Let's continue to B. B. In an attempt to verify the hypothesis, the student researches the fluoride compound of the other halogen and finds the formula ClF3. In the box below, draw a complete Lewis dot diagram to the molecule ClF3. So ClF3. How many valence electrons in chlorine? 7. And how many of them do I have right now? Just 1. So I have 7 electrons. And then fluorine, I have 3 of them, and they're each 7 electrons. So that's 21 electrons. So that means I have a total of what? 28 electrons. So first thing first, I always put the most electronegative element in the center, but in this scenario, because we have 3 fluorines and 1 chlorine, I'm just going to put chlorine in the center, put fluorine all around it, and then I'm going to draw, okay, 1 bond connecting everything first, okay, and all of these bonds used 1, 2, 3, 4, 5, 6 electrons, so that's 22 electrons left. Now, first thing first, I want to satisfy the octet for the central atom. So that means I am going to add how many more electrons on chlorine? Because I have 1, 2, 3, 4, 5, 6. So I'm going to add 2 more. So that's minus 2. I have 20 electrons left over. So now what I'm going to do is I'm going to try to satisfy the octet for every one of the surrounding atoms. And fluorine for this scenario has 1, 2 electrons, so 1, 2, 3, 4, 5, 6 more would do its justice. So 6 here, 6 here, 6 here. If I have 6 times 3, that's 18. That means I have 2 electrons left over after I put all the 6 electrons around the fluorine. So what do I do with this 2 electrons? I am actually going to put it, okay, on the central chlorine, because remember on the periodic table, okay, if you look, we have fluorine and then we have chlorine. Starting the 3rd level of the periodic table, n equals 3, right? Because this is helium, that's n equals 1, and this is n equals 2, and this would be n equals 3. Starting n equals 3, okay, this inclusive and down, you can expand the octet. Can expand octet. Okay, why? Because the d orbitals are empty. Do you remember that? So this would be my Lewis dot structure. So if I were to just draw it out a little bit prettier, it would look like this, right? With lone pairs all around fluorine. Okay, easy peasy. All right, let's continue with C. So C says 2 possible geometric shapes for ClF3 molecules are trigonal planar and T-shaped. The student does some research and learns that the molecule has a dipole moment. Which of the 2 shapes is consistent with the fact that ClF3 molecule has a dipole moment? So first of all, this is actually T-shaped, okay, because it has the 2 lone pairs, right? Because of the 2 lone pairs on chlorine, it's T-shaped. And if you guys don't remember VSEPR and molecular geometry, I can actually create a video on it sometime soon, and then you guys can review that. So here it would be T-shaped, and in T-shaped, because it's asymmetrical and because we have lone pairs here that are kind of like sticking out, this would actually be partially negative, making the rest partially positive. So therefore, it is going to have a dipole moment because it's asymmetrical. Okie dokies? Okie dokies. So, yeah, so let's look at D. Based on concept of atomic structures and periodicity, propose a modification to the student's previous hypothesis and to account for the compounds that form between halogens and fluorines. So, yes, this we can say that an acceptable hypothesis. I guess this kind of makes sense, but an acceptable hypothesis would have to, one, must include, okay, its atomic structure, must include, in regards to its atomic structure, must include the fact that that F atom has odd number of electrons. Okay, and because of the odd number of electrons, because it's not 8, it's 7, we need to create a bond, right? Okay, and in regards to periodicity, okay, periodicity, we can say that the number of fluorine atoms increases as we go down the halogens, okay? So number of fluorine atoms, atoms increase as we go down the periodic table, okay, like the halogen column, right? Because what's increasing as we go down the periodic table? So if this is a periodic table, and as we're going down here, what's increasing? The number of electrons and the number of shells are increasing. Okay, number of shells increase. And that is going to allow for octets to expand. Okay, cool. All right, hope this makes sense. And in regards to Vesper theory and molecular geometry, I can create a different video, and I will see you on the next video. All right, bye.